Hello and welcome, wonderful adventurers. This is the fourth tutorial in the puzzle map game, so let's get started. In this tutorial, we're going to get over into the code, but first I do want to go over this button here. This focus was what I was actually talking about from the last video when I was saying about grab, that you'll see something different. Grab, all that actually does is, like I said, was it actually just grabs the button, and if I changed this here and I change, well, I won't change it in this one because this is a different button, but because I wanted to get to for this one is I realized I didn't show you guys how to set up our button for the music and sound. So what this is just like the other buttons. I chose this to be an Atlas texture. I copied the Atlas texture over and I edited the Atlas texture for pressed and not pressed. And that's all you do for these buttons. And I did add the style, and that was this focus empty. And I will go ahead, actually, that was the other thing I did want to show you too. So I will take that off of there, and then when we play the game, let's focus on the difference between music and sound. So let's go to our pause menu. So if we uncheck sound and we do the same to music, it just made a wire out of me again. Well, what this actually does is sometimes when you're using Windows and you click the button, there'll be a white outline, and that may be because of maybe it doesn't use it uses the focus button in that manner. So let's wander here and take this off, and we'll try it again. And I probably should have left the music off so it's annoying. Cause it's loud, right? You see how this one changed and how that one didn't now. So that's what's going on, and that's why we choose to do that. And look at resume. Not supposed to look like that. So that is that for these buttons and the style. Focus, none. Let's look at the ready button. See what it looks like. We might have some. No, that wasn't ready. It was resume, and it looks like toggle was still on. There we go. So with that being said, now it's time to get into some coding. So we'll get started on that. So when we first open up here, we see that we have a lot of things already laid out. I did all of our functions. I laid out all these variables, and what this actually means is, so this score texture is just the texture that we use here, and I'm preloading it so it can be available when I add our score sprite in brand new. And that's what I do with the score every time is a brand new tiny sprite node. I referenced slot here 1, 2, 3, 4, 5, and 6. And if you crawl back to our animating control, it is in our next piece control, slot 1, 2, 3, 4, 5, and 6. And that's what those are. And the reason why I named them like that was later on in the code when I go to reference them or use them in the code, this is the name that I would have to use if I didn't reference them like that. And the line for referencing them is already long, and I have a large screen, so I can kind of do a lot of this, but this is already the gutter, which is over here, and that's pretty far out, so we don't want, I just do that for shortening. So this is the tile matching dictionary, and what I use this dictionary for is basically every time I run over and do a check, I'll check all the data in the level and of the tiles, and I'll put them in a what I call matching dictionary for all red, all blue, just meaning all the colors are this and all the colors are this. It doesn't mean that they actually match, but the colors match, not their spaces. So that's what tile matching dictionary is. We have a save location and a save file, and we'll get to that in a little bit later on in the tutorial, closer to the end. So just keep in mind that as you see right now it says user, and I will have a function inside of ready that will make it a little bit different for us later on for saving and testing purposes, for testing in the editor, and actually when you export the game, and you can be able to save as well. So available tile spaces and is the heart of our game, and that consists of basically the puzzle map, everything that is in this part of our level. So I'll show you what those, let's look at these numbers again. Now it says vector 2 I 1 2, and we know that the tile map needs vector 2 i's, which is integers. It cannot really accept floats and use a float. It doesn't understand the floats, so we want to pass in integers. So if we take a look here, and if we highlight this and we highlight a tile and we march around here, we can, if we see, this is 0 0, and this one is considered 1 0. So this is your 0 line for Y all the way across, and this is your 0 line for X. And so this is how we start out with it. So we go 0 0, and the reason we come down here to 2, 1 and 2. So if you look at the first number in here, it's vector 2 I 1 and 2, and that's the corresponding number to there. If you look at the last number is 6 and 9, and we look at the map, and that is 6 over and 9 down, and the reason why it's 9 is we had to use an offset for our tile map because of 0 and 1. So it started at 2 and then it ends at 9. So with that, we have a saved dictionary, and like I said, we'll get into that later. We just put our information in, like best score. We put in the information sound and music, and that's the only thing that we save in this game. We can make a more robust save in Godot, but this is just using a simple text file, so nothing really big. So there's our best score, and our score with columns is these 1 2 3 4 5 6, and rows are the rows. And notice here I have that in the function we use an offset for the y at 0 0, just to be a reminder to you when you're in the function and you see the number looking a little different. And this is the reason why. There will be an offset in the function. So we have a start position that we'll keep track of. Wherever the player presses, will automatically update our start position, and also automatically update our end position. It will make it equal to the initial position that the player pressed, and that will allow us to, if the player just pressed where they were at and they didn't move anywhere, and they released the tile, it would just erase the, it would just hide the modulated animated tile that we have for our animation, which is in the animated control. So we'll modulate these to a different color, and we'll play in animation. And when I say a different color, it's just going to be a little bit more brighter, but still the same. So we have a start swap and a start end, and or swap end, swap start, and those are basically the same. So if we look here where swap tile from, when we first push our button and we're on a valid tile, we're going to get a number from that tile from the tile map. And the tile map is going to tell us what we was talking about earlier. It's going to tell us what the source ID is. It's not going to tell us what the terrain is. We're not going to ask it that. We're asking what the source ID is over here. And it will return those numbers, and when it does, we're going to use those numbers for another special function. And that is to and from, of course. We have a small boolean here that can swap, and we use this in a function that is directly associated with our input, and it will force our input to call a little function just to check and see if the pieces are in the map, if they're valid pieces to be moved to. So that's when we play the sound and we highlight the nodes. So we'll use that for that. Check move is a little bit different. When the player drops the piece, when they first press on a valid piece, grab piece gets selected. When they release that, it gets called, this gets turned back to false, and then a function gets called for check move to be checked. And when it checks the move, the player cannot grab any tile pieces while the moves are being checked. And so we know what the sound is, and we know what music is. And locked index is for our touch input. So when we deal with touch input, touch always gets reset when there's no touch. But when a person pushes with one finger, the index becomes 1. If they use another finger on there, then the index will become 2. So for however many indexes or fingers they use, will grow the index. And what we want to do is we want to capture that very first index, the only first time they touch with one finger. If they touch with 2, it's going to grab the one that is the fastest. And of course, there's got to be one faster, I hope, right? So obviously, the process in input will deal with one or the other first, whichever one it determines to be the first. And then it will set our locked index in the input to that input index. And after it does that, it will, and we'll see here because we're looking at the input. After it does that, it sets all these. This swap tile from calls us a virtual function of the tile map, just like this one, and that's why we have the script inside our tile map. And the script being inside the tile map means that we can, if this scene was made in was a scene by itself, and I use this and put it in here, I couldn't just grab nodes and place them in the scene. I would have to basically look them up a different way. So what actually having the script on the puzzle map, we can say we can grab this and we can just add it in. So what we have here is that's what we've done. When the player presses our pause button menu, it will call the pause button to show, and it will pause the tree. And any node in the scene that can be paused will be paused, And we have some nodes that I did also forget to mention that will look down here and we'll go to process, and you see where it says mode and it says when paused. So when the game is paused, these nodes are the only ones that will process, and that's because they are uh, expected to be used during the pause, right? So if it's paused and we push the button and this button didn't and the button was paused, it would never accept the event that it was paused. So that's why we set these four nodes to not pause. And you could do that to music if you wanted to pause the game and you wanted the music to keep playing. You could set it up to do that. Typically, these nodes will pause automatically. There are some tweens that don't pause, so we'll look at that and we'll see the ones that we'll need to set and make sure that they get paused. So when initially we set all these parameters, we get the swap tile from, and then we use this special little trick that I like to do. And what we're going to do is we're going to get a child of our animating controls right here, and that's any one of these. But the special thing we're going to do is that array that we set up earlier, available tile spaces, it's going to look and find that particular tile space, and it's going to find it in the array. And what getChild does is gets an indexed child. If you use getChildren, it will make an array. So getChild is basically a part of an array. When we getChild, we use indexes. The first child is 0, just like an array, because they are an array. Okay? So what we'll do is we use our array, and if the tile is in the very first part, then if the tile is here, what this function does is look up that tile and then grab that color, and then modulated color array swap tile from. And what this is doing is it's getting our modulated array and it's passing in a number that we kind of tricked, and up from here we got the color from here, and now we're going to color our animating sprite with that color. So if we go up to modulated color array, we can see that I have it set on just regular colors, and that's why they look a little bit brighter. So with new slot 1 color, all this does is basically we're storing a variable for our nodes here, our slots. We just want to store a color variable. So when they are ready to be used to drop tiles, then we're dropping the tile that the player sees. And if you look at color array, that holds the color of those tiles. And this does that specifically so we can look through it and cycle through it with an index of a source ID that starts at 0, just like our arrays, which is why it was important for us to keep all of our numbers stacked starting from 0, 1, 2, 3, 4. So we're in our array here, our color array 1, 0, 1, 2, 3, and 4. So that's why we do that. And I have here a special function that is specific to the editor, and it is if the OS has a feature called editor, then that means we're going to be in the editor. We've not exported the game. So we're just going to use our save folder that we have over here for testing purposes. And you can see a file is automatically stored there because every time we exit the game, it saves. So in the beginning, it will load that file and check some parameters to see if it's there. So let's move on because we're not going to deal with that part exactly right now. But in the beginning, we want to just make sure that the labels get reset. We're going to reset colors, Remember our new slot 1 color. We're going to, basically, this is randomly picking and choosing one of our colors and then placing it on that slot from our color array. So, this one I have it blinked out right now because I have my shameless Fog Studios yeah, flash going on there. And so in order to change it and make it random in the beginning, we would just use this. A small simple for loop that runs through all of our available tiles and then sets that cell to the position that the tile is calling in. That's what this is. It's saying give me vector 2i and it's putting it here. And then I'm randomly giving it any color. And we always want to set an atlas texture when we're using animations. It needs to know that it's at 0, 0. If we look at the next function that is being called here, this is where all the data gets checked. This is the most probably unique function because it really does nothing but check the data. And we're going to wait just to see if there's any matches. And we don't want to fire off any of the matches, but we want to automatically load up the matches just in case there are. So when we do push start, the matches get fired off. We have a little wait timer here, just to hold the user's eyes until the ready button is shown, and then we hide the loading label. Once that is shown, then the player can obviously push start. And that is, if you grab this button here, not this button, but the ready button, and you can see that it has a signal on it. And if we click the signal, we'll open up the signal panel. And you see over here where it says pressed, and it gives us a couple of things going on here. And all this is saying is the file path to our main node puzzle map is connected to the script of that puzzle map to a function named start game. And the functions we can set ourselves independently, or we can allow the game to or the editor to set them. So if we come over here and we see where it says resume, and we have on resume button pressed, and we have it linked to the puzzle map, and those are all the same basically. And if we scroll down to the bottom here, this is where I usually try to hide my buttons down at the bottom. So if you push on sound toggle, all it's going to do is make sound equal to toggle. It doesn't have to do anything else. And with music, it's the same. So when we resume, it's going to call out a couple of functions basically and go through a if statement. And if music, and like I said, when we pause the game, if the music is supposed to sound, then we'll unpause it. Say you selected it in there and it wasn't selected before, then we'll unpause it here. Or if you selected it and it wasn't, or if you unselected it and it was selected before, then we'll unselect it here. So that's what we're doing here with only the music. We don't have to do it to sound because they're called during the time that they use the sound. So if we push quit, it will just get tree and .quit 0, and that's just the save code. And then you can see this funny little puzzle game tree exiting. When the tree somehow is exiting, now if you have this as a mobile game and somebody swipes it away instead of pushes our controlled exit strategy, then the tree exiting signal would fire. It will fire all the time when somebody kills the game, whether we quit the game this way, or they quit it that way. So it will fire, saying that the tree is exiting, so it can start deleting its nodes, and it starts deleting them from the bottom. And so when it calls that, basically that's when we want to save the game. And this is for when we drop the pieces. Now, if I do this, this is a method filter. I can skip up and down through our script. So if I go up to unhandled here real quick, and you can see when the player, as soon as they release here, grab piece, if it's true, if they were able to grab a piece, then we're going to drop piece. But if they weren't able to grab a piece, we won't worry about it. We'll also reset this back to -1, and we'll make grab piece equal false. But if the player is still pressing the button, or pressing down, and they want to drag across the screen and move tiles, then as long as our locked index is the same, then we'll call tile map swap pieces with the local event position, and we could pass in the the, the position with the tile map virtual function that converts a global position to a local position, or a float position to an integer position. So we'll call this tile map swap pieces. And you can see that we're passing a vector 2 in, not an I. And then we'll change that to an I here. And I only do that in here just to make it basically local to this part of the function. I only want the function to deal with this part during the time that it's dealing with it. So if the player is moving their stick around or whatever, their finger around, and it's going to call the movement new every single time. So what I did is I added these vectors up, down, left, and right. And what I do is I take the swap start position, and I add these vectors to them. And I could say vector 2i, -1, 0 for vector 2 left, and it would be the same thing, but I figured I'd just do it this way to show you more directly that they're left, right, up, and down, plus our swap start position. And what that does is just make it kind of like a cross. So we're going to use this swap dictionary or swap direction array over here, and we'll ask, out of all 4 of these directions, if our available tile spaces, see how this thing keeps getting used? If our available tile space has it, then we want to do a couple things here. And first we're going to hide our animated sprite, and that's just because we're going to highlight them back real quickly, but we want to hide any that somehow may have mistakenly got left on when they were being moved from one square to the next. This is a catch-all, as I say I do find myself doing quite often. So in this small loop here, because it is very small, and that's why we can do it a lot. It's very small, it doesn't really take up a lot of memory, and it doesn't bog the game down. So if make swap local is equal to I, meaning if our end position is equal to any one of these positions, then we can play the sound if sound is available. And this is a check here to make sure that it's not already equal to the end position. That will keep us from spawning a bunch of dunk sounds when you move from one square to the next. And we magically got the source ID again with the virtual function, and we're going to use that to change some parameters. We'll do a match down here, but first, like I said, we'll highlight the new ones again just to make sure that they got the updated color, and we'll show them. And when we get to here, we want to make this, means we already got a position, and the position is good. So we want to make sure that we set our end position there, just in case the player decides to drop. And what this also does is we make sure that the player, if they go past our end position, that it's not matching in here any longer, and it will, if the player drops the tile or tries to drop the tile, then the tile swap will not happen because basically you're on an invalid square. So it's kind of a check to make you forcibly move these tiles specifically to hopefully stop any random tile movement in a way because your finger grabs another square. So match source ID. We're going to match our source ID, and I named it that specifically so we know in the tile map our source ID, and if it's 0, 1, 2, 3, and 4, we're going to set our swap tile to all of those. And we're also going to set that they can swap, but this is a position inside of our map, and it is one of the valid positions that they're allowed to swap to. If none of that happens, we'll just give false as can swap, and that doesn't affect any movement. All that it does is affect when we drop our tile. So if it's true, as soon as it is true, basically, we'll return out of this function. So when it checks in here, and this is our good check, we come down here and we turn out. Okay. So let's see. When we drop our pieces, we do a couple little special things in here. And first thing we do, of course, is we hide all of our children and make sure we hide all of them here just very quickly. It's only 48 children, so it's really quick, and it just prevents us from having to do a whole bunch of looking around and finds like we did earlier. Since we're just going to make this little simple function here, do a couple of things, and that's first it's going to see if it can swap, and if it's allowed to swap, it's going to say that it's checking the move. That means the player can no longer activate any tiles. And then we'll remember why this is the main reason why we hid them. So when it sets the new tiles here, it's going to set them to our source IDs at our swap positions, and it will immediately check all the data, and it will wait just to check, make sure that the check is completed. For the most part, you shouldn't have to use this away if you don't want to, because it should be extremely fast no matter what. But I just use it to kind of also add a little bit more of a play delay. So we wait, and we also call tile map animate cells, and this is a function that actually returns a variable. It returns a boolean, and if it returns false, then we know that there was no matches. This doesn't tell us if there was any matches. We have to ask if there was any matches first, and if there was any matches, then we'll play sounds. Or I'm sorry, if there wasn't any matches, we're going to play the sound wrong move, and then we're going to set the tile back to its original positions and places, and allow them to for the player to see them go back, and we'll say check move equals false. And no matter what, after we drop swap pieces, they'll be able to swap again, because by the time it does a check, they'll be out of this function. So as we speak about that, let's take a look at tile map check all data. And as I said, all this does is just runs through a for loop, two of them actually, and it's for length in columns, which is our length, and for width in rows. so how far down. And here's the offset. So I put in Y count and I put in X count. And X always is going to start at 1 because when we remember here this is 0 and we're at 1. So X is going to start at 1 always. So it's basically no need to put an offset. That is the offset. Even though it says no need to. So 2 is the offset for the Y. So it's going to run through these, all the tiles that are available. And as they're available, it's going to jot these numbers in here and check and see if there is a tile there. And the reason why it's going to check and see if there's a tile there is it may be checking for a tile map area where there's no tiles, and we can't get information from the tile map where there's no tiles. So we always want to make sure this is kind of one of our safety checks to make sure that the tile has or the grid square actually has a tile in its place. And once it has a tile in its place, what we'll do is we'll reference that node by doing our little neat trick of getting the child based off of make this go away so we can see a little more. Shrink that down. Based off of our find from our X and Y positions. We'll then use our virtual function, give source cell source ID, and we match our cell source ID. And what that does is, like I said, it takes these arrays here that we bring brand new, and the reason why we make them brand new here is so they can just be fresh every time. So we'll add our source ID zeros here, source IDs 1 here, all green, blah blah blah. And if they after that, when it runs through the counter, it counts our X, and when the X is equal 6, it makes the X equal back to 1, and then it adds 1 to Y. And that just allows us to loop through these numbers correctly. And then in the end, it will rewrite the tile map matching tile matching dictionary with the key red with all the red tiles, the key blue, all blue tiles, pink, same, same, and same. And one thing you don't have to worry about with a dictionary, and the main reason why I love dictionaries, is when you're changing variables in a dictionary, you don't have to erase them or do anything. If I say red is this, then red is going to be that. But if I want to add things to it, then I'll have to do a little bit of some things that are different. Now, as we said, this will check this function, tilemap animate cells, and we call this right here to remove the cells and then start to fall. So we want to make sure if there is any availables to drop. So first, this is a private or local function for this here function, or a local variable for this function that I use to reset every single time. And it's good to, in some cases, do this for resetting purposes and stuff. The dictionary, what this means is stay consistent. So since I set it to red, it's always going to be red, even if there was never any red tiles in there. It's going to equal red of what we set to red. So that will always stay persistent. So when we look in there, we look in through the keys, and we check if the matching tile array is first we make a matching tile array, sorry, and then we go into dictionary's keys by tile. So here I'm asking for the key of the dictionary. I'm getting it as a string, and then I'm asking for the tile which is in this key of the dictionary. So the array that I made, I'm asking for this tile, and that's going to give me them as basically like 0, 1, 2 as the index, but it will give me the value of the index. Okay, so when we go down here, and as we said here, notice the check on the values. We don't have to worry about a valid tile check here either, because we're using completely updated information from the tile map. And that's what we did when we did all the data. Get tile map, check all data. So we go in here, and what this is doing is comparing our lefts and rights. So it's seeing if we have any matching thing to the from 0 or any position, if they're left and right of each other, if they match. And if they do match, then we're going to put them in another array in a way that if first we check if it doesn't have it, and because arrays will add the same value twice. And what that means is if you said append the vector to this tile and left every time, if it was the same tile, it would just put it in there every single time. So you'd have a tile size or an array size of maybe, let's just say for an example, ours here at 48, but they would all be the same variables. So we want to check to see if they're not in there, and if they're not in there, then we'll add them. And we do that for up as we do it for down. I mean, left and right, up and down, left and right. So, and after we get all that and put them into this dictionary, we're and this array, we're going to check the array, and again, the available tile spaces are going to pay off here, because we're going to continue to use our find I, our position in the matching. And what that does is again highlight those animating tiles, and changes the modulation and changes the sprite to start playing sad, and then it will show them after it deletes the tile. So it's going to delete the tile, and the reason we want to delete it is because we will be dropping pieces down, so we want to make the tiles deleted, and really that's just about the main reason why we're using animating nodes over using other extra animations inside of the tile map, which we can use, but it would just make, like I said, make it much more bigger and make the tile map something that would be too involved for something this simple. So we make it play sad, and we show it, and then we start a couple of tweens. So sprite tween frames is what we're going to use to tween the animation frames of our sprite. So remember how I said I don't want it to set to auto and I don't want it to loop? Well, this will animate through those frames, and then when it's done with those frames, it's going to call another function called pop sprite, and it's going to bind that sprite to that function, and we'll see here shortly. But then we add one to our matching total pieces. We get all the pops, and then the reason we check right afterwards to see if matching total pieces are equal to 0 is if we don't have any matching totals, and our tile map is also full, so all tiles have dropped. Otherwise, if they haven't dropped, then we want to wait, and we will call our tile map move cells, which will make the tiles drop. But first we're going to pop sprite. If you come down here to this little function, you can see that I'm passing in an animated 2D sprite, and that's just for reference, so we can keep passing it along. I made another tween, and this one is to control the pop animation. And we did the same thing. We're going to tween the frames, and then afterwards we're going to hide the sprite. Now, you could actually do other things, like add other animations. Maybe you wanted the sprite to actually fall, and then we add the cell, the tile, to where the sprite fell. We could do that, and but with this way, maybe you would want to just to add a little bit more oomph. But for me, I'm just gonna leave it like this. But this would be something like how you would do that, similar to that.